Hello learners, welcome to my channel Containers Simplified, and in today's session we will learn about liveness probe in Kubernetes. So liveness probe in Kubernetes is used to restart a container which is causing some issues, like if there is some deadlock or the app is down, so the kubelet can use the liveness probe to restart the container. For example, we have a pod with two containers. It can be like a number of containers in a pod, it doesn't matter, but let's assume there are two containers. So for a liveness probe, we can set it for each container and it is optional. But for production deployments, it is highly recommended that liveness probe is added so that kubelet can restart the container if it finds there is an issue. So yeah, as I mentioned, liveness probe is to check container is live or dead. If it sees the container is live, there is no action, but after some time again it will make a check using the liveness probe, the state of container, is it live or dead. So every few seconds, which we can configure in the liveness probe, it will check. But if the container is dead, the liveness probe fails, the kubelet will restart the container and again it will start monitoring that liveness probe. So when we say restart the container, it is actually a new container in Kubernetes. So we are not restarting the failed container, that is just discarded and a new container is launched in the same pod. And the main use of liveness probe is to provide fault tolerance in Kubernetes. So the way Kubernetes work, it needs fault tolerance, and this is one of the way this is achieved. So liveness probe can be divided into three main types: HTTP GET, TCP port check, or an arbitrary like execute command, like where you can run an command in the container. So for HTTP GET, which is the most common for web APIs, so we check the status code returned by the endpoint. So we can have a dedicated endpoint in our application like health, or you can use your existing endpoint, but the recommended is to have a dedicated endpoint in your web app. If it returns error code 200 or 300, it can be 202, 303 range, then it is considered success. If it is 400 or 500 series, we will consider it error code. It will be, container will be restarted. In TCP port, we just check connect to the port. If it fails, we just restart the container, the liveness probe failed. And in the exec, we just run a command in the container. If the exit code of the command or the script which we run is 0, the liveness probe passes. If it is non-zero error returned, then we restart the container. So this is all managed by kubelet on the worker nodes. So whenever there is error code, the liveness probe fails basically and restarts the container. So we will have a demo application where we will see how this basically works. So this is a very simple, fast API. So if you see, initially it will return healthy status and return code of 200, but after 90 seconds it will start returning status code of 500 and the message unhealthy. So when we start our container for 90 seconds, it will be in the healthy state, and then it returns unhealthy or the status code 500, where our liveness probe should restart the container. So this is just a demo to show how it will behave and how the pod will be restarted, and we can see the events and we can describe our pod to see what messages or events are added by the Kubernetes. So let's build that image. I've just used Docker init to generate the Docker file, and let's push it to Docker Hub so that I can deploy in my Kubernetes cluster. So for now, quickly I'll show you. We will just run it as a normal Docker container, not in Kubernetes, just as a Docker container, and see how it behaves. So I have just run it. Let me do a curl command on the health endpoint, and it will just sleep for 1 second. So it should return me healthy, and after 90 seconds should start returning me unhealthy. So okay, let it run in the background, and this is the pod YAML file or the manifest file where you see the I have added this liveness probe with the health endpoint. You see it started returning unhealthy after 90 seconds. So our testing of our Docker container or Docker image is success. Now we can try the same in our Kubernetes cluster. So let me remove the container, and now we will apply our Kubernetes pod manifest. So there is one already running in my default namespace. I'll delete it before we apply ours, so it will be easier to just check our logs. So there is nothing left. Now let me apply our liveness.yaml file, which is the pod manifest with the only one container, which is our fast API. So yes, the pod is running now. Let it run for 90 seconds where it will be healthy. So let me check the logs of the only container running in that pod. Okay, so if you see now if you see there are entries for HTTP GET for health endpoint. So these all are coming from liveness probe. So every few seconds, the kubelet is querying this endpoint to see is it returning 200 or not. So because we haven't mentioned the delay, and there are few settings you can do for liveness probe, it is taking the default values. You see after few seconds it started returning HTTP code 500 internal error, which is what our application is designed to do. And you see the app is restarted as well. So we are kicked out of that container and a new container is launched, and we can see a restart of 1. So it checks 3 times. The default setting is to check 3 times if the failure is returned, if failure is returned 3 times, the container is restarted, because it can be a case where there is an error for 1 or 2 times, but then your pod or the container start returning health HTTP, say 200, 300. So we will not restart the container. So the default is to check it 3 times. So it can be changed in the manifest file, but we check. So if we describe our pod, we can see the exit code of 137, which is for sick term, I think, or sick kill, and the restart count of 1. And we can see the liveness, what the definition we have is HTTP GET, our endpoint, the port, and the failure count of 3. And if we go to the events, we can see in detail. So there is a unhealthy container with a liveness probe failed with a HTTP status code of 500. So this is really, really helpful. We can go to the describe the pod and see all the details. And as I mentioned, we can increase the initial delay second. So this is where you mention, and the period seconds. So I hope this video was useful to you to have this strong how we can use liveness probe and how it helps with the fault tolerance. So I will be back with another useful video. I hope you enjoyed this video, and please give me some review comments, and I will try to improve in my future videos. Thank you very much for watching.